In the Interpreting COVID-19 Data assignment, you will learn how to interpret, write, and evaluate linear equations with two variables that model real-world situations. You will also practice communicating a thorough understanding of the topic of your writing. Let's jump down to the example. In this example, we're looking at COVID-19 new cases during 1 week in the United States. This is between February 9th and February 15th. In the first question, you're asked to identify the Y-intercept by answering the question, what was the 7-day average of new cases on February 9th? If you take a look at your graph on February 9th, over here, I've already selected the 7-day average with an oval shape around it. That is 108,152 cases. So you would go ahead and type a sentence such as this one. The 7-day average of new cases in the US on February 9th was 108,152 cases. Next, to find the slope, you're answering the question, what was the rate of change in the 7-day average of new cases between February 9th and February 15th? To answer this, you have to know the change in the number of cases for both 7-day averages on the 15th of February and on the 9th of February. And then determine the number of days that have passed between the two dates. Let me go ahead and show you how to set up this equation. Here I typed 85,812 minus 108,152 because on February 15th, the 7-day average was 85,812. So we start with this newer number of average cases and subtract the original number of 7-day average cases, which was the 108,152. In the bottom part of the fraction, the denominator, we're subtracting 15 minus 9, which represent the 15th of February and the 9th of February. Now when we subtract the top values, we end up getting a negative, which is why I typed this negative in front of the fraction. That's 22,340. And then the 6 represents the change in number of days, which was 6 days. Now we can divide the two values, and we get negative 3,723. So what does this mean? This means that the 7-day average of new cases in the US dropped by about 3,723 per day between February 9th and February 15th. We're going to take what you just came up with in answers A and B and put those together to write one sentence for part C. In part C, to write a sentence describing the initial 7-day average of new cases and the rate of change, I'm combining parts A and B to say the 7-day average of new cases was 108,152 on February 9th and dropped by about 3,723 per day through February 15th. Now part D. To write an equation in the slope-intercept form that represents the daily change in new COVID-19 cases between February 9th and February 15th. We're going to use this format, y equals mx plus b. However, recall that I tell you in real-world situations, I prefer to think of this as y equals b plus mx. Start with the y-intercept. So in this case, we start writing y equals, and the y-intercept, which you identified up here in part A, is 108,152. And then the slope, or the m, is the value you came up with, or we came up with here in part B. That is minus 3,723 cases per day, where x represents the number of days. That is the equation. Lastly, to evaluate, we're going to answer this question. At this rate, what will be the 7-day average of new cases in the US on March 1st? I gave you the hint that the total number of days that takes place between the two dates is 20 days. So between February 9th and March 1st, that is 20 days, which is why I take the equation we came up with in part D, and I plug in the number 20 for x, which is the number of days. Now from here, it's a matter of simplifying. Multiply 20 by this value, and we get 74,466. Now when you subtract this original number of cases by this new value, we go ahead and simplify to get y is equal to 33,686. So what does this mean? This means that if the number of new cases continues to decrease at this rate in the US, then the 7-day average will be about 33,686 by March 1st. So again, this is assuming we can use and we'll be able to use a linear model to represent this trend for a given number of days after February 9th.